It's a really simple class. It's just backed by active record. So when you instantiate a finding object, it just logs it in the database. And then there's a test RB is our base test class. So this is the parent class of all the test modules. It has some common functionality that's used across test modules, so you don't have to rewrite it on each one. And then it implements the file helper module that allows us to test within files. So we're not redefining that everywhere. Any test that needs to look within a file for contents can just call this method, and it's already taken care of. And then the individual tests themselves derive from the base test. They have an init method that just basically defines some metadata, the name of the test, the severity of various findings, et cetera, and then a run method that runs the test. So we're trying to keep things simple by having a sound object model and keeping all of, well, not all, but keeping a lot of the the heavy lifting out of the tests. So here's an example of a test file at the end of the day. This is a pretty simple one, just checks for a bash history file. If it exists, it looks within that bash history file for things that we've defined as as potential key materials or credentials. This one's similar here, although I got the title of the slide wrong. This one's SSH authorized keys. So this is where we're looking for any authorized key file, looking within that file to see if there's any keys present other than the one that is provided through through the Amazon interface. So this will identify unknown keys. This one's a little bit more complicated. It was an attempt at trying to catch any sort of persistent connections. So we're looking at a netstat and seeing if there's active connections from the host, excluding a few IPs. Not going to look at loopback connections, not going to look at connections that are coming from my test box, et cetera. This isn't terribly effective because it has to be a really long-lived connection in order to be caught. If you're doing something like hitting SSH and downloading a script, hitting an HTTP server and downloading a script, that's going to be a really quick connection, and the odds that we would catch that are pretty slim. But if somebody had an SSH session persistent for a long period of time, and we happen to test at the right time, there's a chance. So let's talk about the scope of our testing. We started with the idea of looking at all US East images. We removed Windows images from the scope. They're generally paid images because of licensing constraints, and they're more difficult to interact with remotely because you have to do it all over RDP. It's a little harder to programmatically access. So that left us with 5,515 non-Windows images. This was the list of images that we attempted to process with the tool. There were 771 images that were paid. So you need to have an additional license, pay an additional fee to use those, and we just kind of skipped those because we were trying to keep costs under control. There was 2,767 that failed to test, and this is really kind of interesting. It seems like almost all of these were due to some sort of error with the image itself. So you saw the one that I had where my SSHD was broken. That was a private image. It's broken. Why would I make it public? But it seems like a lot of people make these public anyway. So you can't. I couldn't interact with them over SSH because they won't start. Get kernel panics on boot. You can't find the root volume on boot. SSHD doesn't work, etc. So we ended up with 1,977 images that were scanned by our tool. We had 580 unique images that had one finding or another. So that's 29.3% of the images that completed all the tests had at least one security problem. We shared these findings with Amazon's security team. We didn't verify any of the credentials. We didn't attempt to use any of this stuff. So it's possible some of these have been revoked or something like that. I have no way of knowing. And Amazon's been responsive about trying to contact the image owners and the users if it's applicable, and make everyone aware and remove images if necessary, etc. So I really want to applaud Amazon's security team. They take this threat seriously, and they've been tremendously cooperative with us. So the largest finding was the problem of SSH authorized keys. I suspect that many of these are people that just didn't realize they were there. they're probably not, it's hard to say how many of them are malicious. But the fact is, when you download an image that has an authorized key file, whoever has that private key, if they can reach the SSH port, can authenticate. So there's no real way to separate what's accidental and what's malicious. It's a pretty severe finding. So 19.52% of the AMIs we tested, nearly 20%, had an unknown authorized key file. So, by that statistic, if you randomly launched 5, public AMIs, there's a good chance that somebody else has access to one of them. This represented 44.96 of our findings. So it's far and away the most prevalent problem that we've encountered. This chart here breaks down all the different findings that our various test modules, encountered. The number of occurrences of each, the number of unique images that was affected by that finding, the percentage of our total number of findings that were represented by that class, and the percentage of AMIs that had that problem. The percentage of okay, so that's the percentage of all AMIs with findings. So if we take the number of images that had unauthorized SSH keys as the numerator, and the number of images that had some problem, that we discovered as the denominator, that's what that percentage represents. Then we have the percentage of our test case. So we see there again, unauthorized SSH keys existed in nearly 20%. I believe the German researchers, their number was 30%, but I'm not quite sure what the scope. They tested 1,000 images. We tested nearly 2,000, so that's going to vary a little bit. And I'm not quite sure what region they tested. I sort of suspect it might be EU, just because they're from Germany, but I'm really not sure. So I don't know how directly comparable our findings are with each other, but it seems we're both in the same ballpark. Our second highest finding was just the existence of a history file. So that in and of itself may or may not be a significant finding. If that history file contains sensitive environment variables, key materials, et cetera, we would log another finding. But in some cases, the history file might have have some sensitive info that we weren't scanning for. The other tops there, environment variables that are commonly used to point to Amazon Web Services key materials. The access keys themselves, that's a significant one. It's not a huge number of images, but with those keys, essentially, if we'd wanted to, if we were so inclined, we could have scanned until we found one of these, and then continued the project, by using that credential, and reduced our costs quite a bit. But we're not trying to be criminals here. We're just trying to gather the scope of the problem. Other issues, SSH identity keys. So that's the actual private key, which is kind of unusual. In at least one case, I was able to find the identity key file, and then go back to the history file and find a remote hostname that they'd logged into with that identity key. So chances are good if I'd used that same key against that same host, I probably would have gotten that host, which isn't on Amazon's cloud, but may have had its security compromised as a result of this this lax practice of keeping the key there. And there's various other findings, much lower proportion, so I'm not going to discuss them all. The SSH password authentication enabled, we actually added that test as we were most of the way done with our scan, so those numbers are really incomplete. But that's a module that's looking for an SSHD config that has password auth enabled. Amazon Web Service EC2 is really built strongly around key authentication. So if you have password authentication, now the strength of passwords and accounts that are configured on the image comes into play. So we didn't find a whole lot, but as I said, we didn't test all these with that test. So let's talk a little bit about the costs. Excuse me. My Amazon Web Service bill last month was $1,333. I completed all these tests within the month, and the vast majority of that is due to this project. It's a little too bad. $3.84 more, and I would have been at $1,337. So that would have been kind of cool, and Yeah, I wish I would have figured that out. I wonder if they'll let me overpay the bill, you know? Like, just here's 384 more. Like, anyhow, that breaks down to 67 cents per image scanned, 98 cents per finding, $15.68 per Amazon Web Service credential. So that seems like a bargain. You know, with a little bit more manual review, we might find that some of these things are you know, that are you know, for example, a batch history file, if you were to look at it, you might be able to find other things and have more findings. Kind of conversely, you know, you might find that some are more false positives. So our numbers are obviously rough, and the costs per finding are you know, a little bit rough there as well. We could have leveraged spot instances to lower costs. So spot instances use off-peak pricing. You know, if you don't care when you run a task, you can run it whenever Amazon has more capacity available at a lower cost. It would have made the scripts a little bit more complex to, you know, to keep state of what machines are running and not. And there's also the thought of analyzing the EBS boot images themselves without, you know, without launching the instance. This might reduce costs. It might also increase the amount of images we're able to test. Some of those public AMIs that wouldn't boot properly, if they have a valid EBS volume, that volume might still have data on it. You know, the fact that the machine doesn't boot doesn't mean there's, you know, no data there. And I sort of suspect that, you know, if someone's going to go to the trouble of making a broken image public, they're probably not going to be following some of the best practices in securing their, you know, their credentials as well. So that might be interesting. And again, as I said before, you know, if we were malicious about this, you know, we could have reduced our costs pretty greatly. Let me go back to our test there. That should be just about complete now. 10 minutes? Oh, wow. Okay, I'm going to have to pick up the pace here. Okay, so keep changes. Okay, so this is our test here, and you can see those two threads completed, those tests completed. If I go into the log at AMI's directory, this might be a little hard to read at this size, but let me look at the log file for the first one here, 04BE. So, yeah, it doesn't wrap around too well here with this size. Is that, maybe I can shrink it, well. Anyway, you can see here, you know, it starts up at the beginning, launches an instance, it's got the instance ID number there, attempts to SSH to it, SSH hadn't started yet, so it sleeps for a little while, discovers the SSH username, and then starts running tests. This particular image didn't have any issues, so it runs a test, completes a test, runs a test, completes a test, etc. Not a whole lot interesting there. It eventually terminates and shuts down. If we look at the other test, this one's a little more interesting. So same sort of thing, start an instance, discover SSH. Now there you can see we found an unauthorized SSH key. We called that high severity, and there's the key. You know, we checked for X509 certificates, found a certificate file. There's the file name and path. And it just kind of continues on like that with the various findings. These are also all stored in a database. If I go back to, I'm using SQLite here, but it's active record, so you can use whatever adapter you want. Select start from findings, and you'll see we've got our database there. You know, that logs all our findings, where things were found, and the details that go along with them. So that was, you know, that was a demo showing two machines being scanned in real time. At our peak, we were scanning about 110 images an hour. Now, when I say scanning, that includes identifying images as paid images, which obviously doesn't take very long. But yeah, that seemed like a pretty decent rate. It took